This is part 2 of the rectification in ERDAS Imagine using the ribbon interface tutorial, and in this particular tutorial we'll be talking about using an orthorectification which utilises a DEM. Right, first things first, we'll pick an image to rectify, so we'll drag him into the Imagine window. I have it open on another screen in Windows Explorer, and now the program is building pyramid layers to speed up the display of the image, which will take 10 or 20 seconds or so to do. You can see the progress bar going across the screen, so when that's finished we can actually fit it to the window. Okay, that's finished. Click back in the background, right click on the main window, fit to frame, and there is our image ready to be rectified. Now in this case we have to use a different system to the basic rectification. You might remember we used a polynomial format to rectify the image before. This time we'll click on multispectral again under the raster tools. We'll again click on control points, and when the window pops up, instead of scrolling down and picking polynomial from the list, we'll actually pick camera from the list. Now this will mean that we need to have quite a few different parameters entered into the model to enable the rectification to take place, and the first thing we have to do is select our image layer that we wish to use as the reference layer, and that's automatically the default selection highlighted in this tool. So we'll click OK. We'll go to our directory where the image is. We'll select an image, in this case an ECW image based on ADS camera, and it will pop up with a summary of the coordinate reference system, and we can accept that. When we accept that, we get this camera model properties dialog box. In this case we're going to use a file for our elevation source, and I'll have to zoom to and find the appropriate DEM for this particular model, which is the DEM that came with the ADS dataset for the 100,000 sheet on which this image is located. So we've selected that image file. Sometimes you'll get an error message pop up here. Pay attention to it because it could mean that your DEM is actually outside the area of interest, or there may be other issues. We'll have to enter the principal point of the photos. This data is held in on the network. In this case it's -.002 for the X coordinate and 0.004 for the Y, and I know that the camera is 152.76 millimeters focal length. Once we've entered in this basic information, we don't account for the Earth's curvature. We have to locate the fiducial information on the for the camera on the image. Now to do that we have to select the fiducial viewer locator and click on this icon to toggle the background viewers for fiducial location as opposed to ground control point location. Select your arrow cursor. Again, we can lock the cursor if we wish using the icon here, but we'll go across to the control point locating window, which in this case is being used for the fiducials. Drag the selection box up to find where the fiducials are located. Use the next selection box to highlight the fiducial in the top right window. Do not use these icons, but use the ones in this window. Select the crosshair symbol, place the crosshair over the fiducial point and select it. Make sure that your arrow is selected, which it'll default to after you have placed the fiducial mark. If the tool is not locked, if the tool is locked, you'll have to reselect the arrow. Drag it across to the next fiducial, highlight it in the magnifying box, again select your crosshair, drop the point. This will have defaulted back to the arrow key. Drag it down to the next fiducial point, again, locate the fiducial point, drop the mark, find the last one, select the crosshair and drop the point. Now we've selected the 4 fiducials, we have image coordinates for the 4 fiducials. I need to enter in the actual camera calibration information for the film X and film Y for this particular lens, and it's not the camera, it's the lens. Okay, now I've gone to the camera file, I've found the information I require, and you'll see that I've entered in the film X and film Y for each of these fiducial points. Okay, so now we have the fiducials located, you notice the image coordinates, we have the film X and film Y from the calibration information. Now this image was actually thrown from west to east, so we need to set kappa to 180, which is also in our saved information on the network, and we need to make sure our projection is correct. In this case we have GDA 94 ICSM for the horizontal projection, and the vertical coordinate is WGS 84 and the worldwide height. So we'll set the vertical coordinate to a GRS 80, and it defaults to the Australian AUS 98 GRS 80 datum. So we'll accept that. Notice it's changed here, and that way we can actually now close the calibration camera properties file, and we're ready to start collecting our control points. Now make sure that your arrow icon is selected. Right click on this window and fit image to window. I like to do it this way because I can see where I am. Fill the bottom window with the entire image. Zoom to the same area on the reference image. I'll make that a little bit bigger. Okay, that's a little bit too big now. Okay, so here basically we have something like the same area being shown on both images. Our referenced image on the right, and if you look down the bottom of the left hand corner of the window, you'll see the coordinates are actually shown down there in the window. I'll resize this a little bit so that we can actually make sure we can see everything. Okay, and on our reference, on our image to be rectified, you'll see that it just has image coordinates. Okay, so first things first, we'll enlarge our little selector box here, pick an area that we can recognise on both images. You'll see that it's showing in the top right hand box on this side, top left hand box on this side. We can select our crosshair tool. It's waiting for our first control point. The program is playing silly buggers again, and we can actually place our first control point, which I'll dump in the middle of the dam. Reselect our crosshair, and you'll see now that down the bottom of the screen we actually have the X and Y coordinates in the image, the X and Y coordinates on the ground for that control point, which is located in both windows. The tool has dropped to be ready to collect the next ground control point, so it's a matter of making sure the arrow cursor is highlighted. We drag our selection cursor to a known point, and then we can actually collect the next control point in sequence. Simply select your crosshair, select the point on the ground, reselect your crosshair, select the same point on the reference image. So there we have two control points located. As I said in the previous tutorial, you can select the lock icon, which just locked the arrow cursor. We can drag that to a known point. Let's say this one here. Do the same in this window. select the crosshair, drop a control point, no need to reselect it because the lock cursor is holding it. Select our arrow cursor and move around and collect the rest of the control points, which I'll now do whilst I pause the recording. Okay, I've now collected a spread of control points. I have 9, and my control point error down the bottom of the screen is 0.0023. I can now click on the resample image dialog, surf to where I want to save the image, give it a recognisable file name. Okay, use bilinear interpolation as the methodology. We have our file, which is our DEM, selected. We have our output cell sizes selected, ignore 0 in stats, and we can now actually undertake the resampling process. Okay, that process is now underway with the resampling. I hadn't configured this particular machine. There's a known issue on some machines that the 64-bit resampling process won't work, so you have to make it default to 32-bit. That's why the big red line's on the screen. But now it's undertaking the resampling process, and I'll show you the results in just a moment. Okay, now that process has been finished, so I've actually loaded the reference image into the frame, and I've also loaded the image that we've just corrected into the frame, and I can zoom in on them and use the swipe tool to check the alignment of the rectification. And there we are. We have our ortho-rectified image overlain on the reference image, and that is the end of the second component of the ortho-rectification using the ribbon interface in Imagine. Enjoy.